Hello, everybody. How's it going? Happy day, happy day. We are going to fill out the last part of our factoring foldable today, which is it's a combination of all the different types of factoring. So we're going to look at how do I know when to factor, right? How do I know what method to use when I'm asked to factor? So when we have questions that ask us to factor, most of the time, those questions are not going to say factor by taking the greatest common factor, or factor by grouping, or factor this perfect square. Like, it's not going to tell you how to factor in the problem. So it's just going to say factor. And so arguably the hardest part is figuring out how to factor. And so that's what we have here on this last page, is just a checklist for us to go through. And we can use this checklist to figure out how we're going to factor things. So first thing we should always check for is the greatest common factor, okay? Let's see if yep, perfect. So if I have a greatest common factor, I come down here to 6 and I factor as necessary. And then I check to see, can I factor again? So I always have to check to see, can I factor again? If there is no greatest common factor, then you move on. Does it have 4 terms? If it does, you're going to factor by grouping, right? So you come down here and you'll factor, and then always check to see if you can factor again. Does it have 2 terms? So if it has 2 terms, it might be a perfect square. My thing's not on. That would help, right? If it's a perfect square, then it would be in the form of that a squared minus b squared. Okay, so that's what you would check for if it had 2 terms. So if it is, then you would factor as necessary and then see if you can factor again. If it's a trinomial, it might be a perfect square trinomial. And if you don't recognize that it's a perfect square trinomial, it's okay. That's just a shortcut, so don't stress about it. And then lastly, it might be in this form of ax squared plus bx plus c, where a could either be 1 or a could not be 1. So once you figure out how to factor, then you factor, and then you check, can you factor anything again, right? And so like if I determine that I'm going to factor when a is 1, right, and then I'm like, oh, I don't remember how to factor that, then I can go to that spot in my foldable and I can look there and remind myself, how do I factor when a is 1? So what we're going to do is we're going to do a couple examples. The last thing is, if the problem asks you to solve, you have to use zero product property. So you're going to factor everything just like normal, but then once you're done, then you have to use zero product property. And so our third example, we'll do that. But for example 1 and 2, let's just focus on practicing factoring. Okay, so example 1 is that we are going to factor 5x squared plus 15x plus 10. Barely fit it. Okay, and so I don't know how to factor this, so I'm going to go down the list. Does it have a greatest common factor? So I have 5, 15, and 10, so yes, it does. So since it does have a greatest common factor, I'm going to come down here to step 6 and factor. So my greatest common factor is 5, and I cannot pull out an x because there's no x on this 10. Okay, so I have a 5 times, and that leaves me with x squared plus 3x plus 2. Okay, so I factored as necessary. Step 7 says to check to see if you can factor again. So I'm going to ignore this 5, right? The 5, just ignore the 5 for now. It's there, but we're just going to ignore it. Don't cross it off on your actual notes. Okay. And then I'm going to go through and I'm going to look here. Because this has an x squared, I might be able to factor it again. So does this have a greatest common factor? No. Right? Does it have 4 terms? No. Does it have 2 terms? No. Is it a trinomial, 3 terms? Yes. Is it a perfect square trinomial? Well, x squared is a perfect square, but 2 is not a perfect square. So it's not a perfect square trinomial. So it's in this form, ax squared plus bx plus c. And a is 1, right? The number in front of x squared is 1. So I'm not looking at the original a, I'm looking at the factored a. A is 1. So this should be pretty quick because a is 1. I just want two numbers that multiply to 2 and add to 3. So two numbers that multiply to 2 and add to 3. The only two numbers that multiply to 2 are 1 and 2 and -1 and -2. And since I want it to add to +3, it's going to be +1 and +2. So I have x plus 1, x plus 2. And then now that 5 is still there, right? It was there the whole time. I just ignored it. And so now the 5 is still there. And that is factored because every single one of these terms is x to the 1, right? This is x to the 1. This is x to the 1. I cannot factor anymore. I can only consider factoring if I have exponents that are greater than 1. And that's it. I factored it. So these problems, just because you factor it once doesn't necessarily mean that you're done, right? We factored it once to take the 5 out. Then we had to factor it again to get this down all the way factored. Okay, let's look at example 2, which says to factor 7x cubed minus 63x. Okay, so here I'm curious. I do have a greatest common factor. That's my first term, or my first thing I check for. Here, my greatest common factor, I can take out a 7 in both of these, and I can also take out 1x, right? I have 3 x's here and 1 here, so I can take out 1x. So let's write that. I have 7x times. I'm left here. I took out the 7. I took out 1x, so I'm left with x squared. And then -63 divided by 7 is -9. And I took out the x, so that's it. So I factored by greatest common factor. Now again, I'm going to ignore this 7x, and I'm just going to look at x squared minus 9. Okay, so does that have a greatest common factor? No, right? Does it have 4 terms? No. Does it have 2 terms? Yes. Is it a perfect square? So is x squared a perfect square? Yes. Is 9? Yes. And it's subtraction. Remember, it has to be subtraction. If it's addition, you cannot do it. So in this case, it is a perfect square. And if you don't remember how to factor a perfect square, right, go back in your foldable and find the perfect squares and remind yourself how to factor using a perfect square. That's what the foldable's for. Okay, so here when I take, when I factor this, I take the square root of my first term, which is x, minus the square root of my second term, which is 3. And then my other parenthesis is going to be x plus 3. And then my 7x is still there. And so I'm going to ask myself, right, this is x to the 1, so I can't factor it. This is x to the 1, can't factor it. This is x to the 1, can't factor it. So since they are all factored all the way, that is my final answer. Okay, so again, just because you factored once doesn't mean you're done. Check to see if you can factor again. Okay, last example we're going to look at here is example 3. And example 3 is asking us now to solve. So I'm going to solve 3x to the 5th minus 48x equals 0. Okay, so again, first thing I check for, does it have a greatest common factor? Because I'm solving, I have this equals 0. You can ignore that, okay? You don't have to do anything with that in terms of factoring. We're going to deal with it at the end. So ignore the equals 0 part. We're just looking at these two terms. So this does have a greatest common factor. Okay, and my greatest common factor here is 3. And then I can take out 1x as well, so 3x. So when I take out a 3x, I'm left with x to the 4th. The negative 48 divided by 3 is negative 16, and I took out the x. So that equals 0 is just going to work its way down, but we're not going to really do anything with it yet. Okay, so then ignoring the 3x, this does not have a greatest common factor. It's not 4 terms. It is 2 terms, and it is a perfect square. I have x to the 4th, 16, and a negative. So if I factor that, I get x squared minus the square root of 16 is 4, and then x squared plus 4. And then the 3x is still here. And I still have x squared, so I have the potential to continue to factor, so I'm going to check again. Again, I'm going to ignore the 3x, and I'm going to just look at this one. The x squared minus 4. Okay, there's no greatest common factor. It's not 4 terms, it is 2 terms. X squared and 4 are both perfect squares, and it's a minus. So I can factor this again. Square root of x squared is x. The square root of 4 is 2. So I have x minus 2, x plus 2. And then I still have this x squared plus 4, which we'll look at next. And I still have the 3x. Okay. So now these are all x to the 1 except here, right? So if I go through the list, there's no greatest common factor. It's not 4 terms. It is 2 terms. X squared is a perfect square, and so is 4. But it's a plus, not a minus, and so this is not factorable. I cannot factor this because it is plus 4, not minus 4. So I'm actually done factoring. Cannot take this one any further because of the plus. So if I was just asked to factor, I would be done at this point. But I'm not asked to just factor, I'm asked to solve. I want to know, where does this graph cross the x-axis? So I'm going to take every single factor, right? Every single, so I have 3x, I have x minus 2, x plus 2, and x squared plus 4. So all 4 of those factors, and we're going to set them equal to 0 and solve. That's the zero product property, okay? So I'm going to set 3x equal to 0. My next factor is x minus 2, so x minus 2 equals 0. My next factor is x plus 2 equals 0. And my last factor is x squared plus 4 equals 0. And I'm just going to solve all of these. So first one, divide by 3, divide by 3. And I get x equals 0. So this tells me that the graph crosses the x-axis at 0, 0. So there's one. Second one, if I solve for x, right, we can add 2 to both sides. And I get x equals 2. So it also crosses the x-axis at 2, 0, right? Because my x value is 2 and 2 comes first. My third one, if I subtract 2 to both sides, I get x equals negative 2. So it also crosses the x-axis at negative 2, 0. And then the last one, we subtract 4. Right? I get x squared equals negative 4. I take the square root. I can't take the square root of negative 4 and get a real number, right? I'm not allowed to do that. So this one is just no real solution. And it's really important that we put that word real, no real solution, because there is a solution, and we're going to talk about it next semester. You get an imaginary number, but for now, there's just no real number that works, right? I don't square a number and get negative. So what this is really just telling me is that the graph is crossing the x-axis at -2, at +2, and at 0. I didn't space that out very well. So the graph is doing something like that. And you don't have, I'm not expecting you to know how to graph this already, but just to show you what these mean, right? It's important that we know what we're solving for. Great, I solved the quadratic formula, but who cares? Why? What did that find me, right? So you're finding the x-intercepts. You're finding where the graph crosses the x-axis. Okay, so you guys have some practice on this. If you have any questions, make sure you reach out. Again, use this checklist to go down and figure out, how can I factor this? Can I factor it again, right? A lot of the times you can factor more than once. And keep in mind too, it is possible that something is not factorable. So if I give you a regular problem, like from the beginning, if it doesn't match any of the criteria, it might not be factorable. So that's always an option as well. So again, let me know if you need help. Otherwise, good luck on your practice, and we'll see you soon.